want to calculate V final. Now, when the ball actually reaches the ground, go up to the picture here, it will be headed like so. This is its V final. So just like it before, make that red, I think it'll be better. Just like it was before, it has both a vertical and a horizontal component. This is its vertical, V final Y, and this is its V final X. So to tackle this problem, I need to calculate both V final Y and V final X. And then I'll use the Pythagorean theorem to find the overall final velocity. Well, the good news, V final X is very easy. Remember, there's no acceleration in the x direction, so V final X is the same as V initial X, which we calculated first thing as 14 meters per second. I do need to figure out V final Y. That involves a calculation, but I'm going to find it using the acceleration formula. And I know all these values. In this problem, V final Y is what I'm trying to find. I'm sorry, let's back that all up. The acceleration is negative 10 meters per second squared. V final Y is what I'm looking for. V initial Y we calculated to be 5.1 meters per second. And now I need to enter a time. And the time I'm looking for here is the total flight time. Because I'm looking for how fast the ball is traveling right when it hits the ground. So after 3.01 seconds of flight time. So when I solve for V final Y in this equation, I'm going to get negative 25 meters per second. Negative because it's going down. Now, I can go back up here and finish this out. 25 meters per second. Negative squared plus 5.1 meters per second. And I can figure that out. I end up with V final (25.5 meters per second). So that's how fast it's traveling overall when it hits the ground. Last but not least, I don't know. Final question. Calculate the range of the ball. Quick reminder, range means delta x. How far it goes horizontally. This is actually the easier of the two calculations in terms of distance because ax is 0. Remember, the ball doesn't speed up horizontally. Time for the entire time it's in the air is 3.01 seconds. The velocity is 14 meters per second. So I'm going to use delta x is v naught x times t plus 1/2 ax t squared. I can get rid of this last term. Delta x will be 14 meters per second times 3.01 seconds. So 42.14 meters will be my final answer. And that concludes this projectile motion practice problem.